Sketching is a really important part of the calculus. Now, this particular section dealing with finding maximal, minimal, and increasing, decreasing, where the function is increasing, decreasing, and also talking about second derivative a little bit about concave up and concave down. But while we're learning how to do a curve sketching, those concepts will also be included in this presentation. So just remember here a couple of things. If you want to sketch a curve with our calculator, step one, test the functions. Okay, we let f of x equal to 0. When we let f of x equal to 0, that's how we find x-intercept of the graph. And f of 0 is finding the y-intercept. And find any horizontal or vertical asymptotes. We can look at that into a little bit more in a minute. Then step two, look for maximum minimum points. How do you find them? Maximum minimum point will occur when the slope equal to 0. In other words, the first derivative will equal to 0. So if we take whatever the function is, we take the first derivative. If we set it equal to 0, then that's where the possible maximum minimum point. Then we go ahead and test the interval to the left to the right of it. If the first derivative is greater than 0, then the curve is rising or increasing. And if the derivative is less than 0, then curve is falling or decreasing. So if you have a point, if you find yourself for x in the very first step, and then you find out the curve to the left and to the right of it is rising followed by falling, then you have rising followed by falling, then you know you have a maximum point, and vice versa is true. Now, if you do the second derivative, that's where we find, if you let the second derivative equal to 0, that's where we find what we call the inflection point. Now, inflection point function the same as the first derivative, except this time you're dealing with concave up and concave down instead of increasing and decreasing. Then, of course, the last step will be test the end behavior if you want to sketch a curve without graphing calculator. So here's the example. So if say we want to sketch y equal to x cubed minus 12x using derivatives. So let's find out the intercept. So x-intercept, that means we're going to set our function equal to 0. Once you use algebra, we solve the x equal to 0 and plus minus radical 12. So that's your x-intercept. That's this right here, this one, and that one. Now to find a y-intercept, we simply let x equal to 0 and plug it in and then find y. So we find out y-intercept is at 0, 0, which is also that point. Right, so we have our x-intercept at these 3 points, and we have the y-intercept right here. And there's no horizontal asymptote or vertical asymptote because this particular function is a polynomial. It's not a rational expression, so there's no domain issues. Okay. Now, the second step, let's find our maximum minimum point. So we take the derivative of our function. We get 3x squared minus 12 set equal to 0. Once we solve for x, we get plus minus 2. We plug in 2 into the original function. We find out 2, negative 16, and negative 216 are the 2 points that's possible maximum minimum. So if you look 2, negative 16, which is right here, there's your minimal. And 2, negative 216, there's your maximum. Okay, so that's where it is. Now, again, how do you know that's the maximum or minimum? One of the way you can test is using second derivative. If you take a second derivative, okay, so you get 0, 0, 0, 0. That means if you say take second derivative set equal to 0, you find inflection point. Now, inflection point means where you have a concave down, switch to concave up. When there's a switch between concave up and down, you have an inflection point. Now, but furthermore, what's important is if you take the second derivative, okay, now if we plug in 2 and negative 2 that we find earlier, this is called a second derivative test. If you plug in negative 2, you'll find out you get it. So at negative 2, back when x equal to negative 2, you take, because we know that you get at 2 and negative 2, you have a possible maximum minimum point. Now, how do you maximum minimum? What you do is, like, for example, how do you know this point is going to be maximum minimum? You take this negative 2, plug into the second derivative. It turned out to be negative. Negative means concave down, according to the second derivative test. So at this point, you can expect your function is concave down. Now, concave down also means what? Maximum point. Then the vice versa is true. if you want to test out 2 at this point, how do you know it's maximum or minimum? If you take 2, plug into the second derivative, you'll find out it's a positive number. Positive means what? At 2, you can experience a concave up. Well, concave up translate into a minimum point. So for this graph right here, you have a relative maximal, relative minimum. This well, absolute value, absolute maximum and minimum can be defined depends on what you're looking at. Since we're not giving an interval, okay, so we don't know how far this one will go. So we don't necessarily have a maximum, absolute maximum or minimum. Now, this question is the same, so I'm going to go ahead and skip that one. Now, I want to show you something that's a little slightly different. Okay, let's look at this example. Okay, right. So sketch this y equal to 2 minus x to the 2/3 power. Now we're going to find out x-intercept by doing the same thing. Set our function equal to 0. We solve for x, so we get 2 radical 2 and negative 2 radical 2. That's our x-intercept. And our y-intercept, once we plug in 0 into the original equation, you get 0, 2. Again, no horizontal asymptote or vertical asymptote. But however, when you take the derivative, you're going to find something interesting, okay? You're going to find that you can solve for it. So that means you don't have, so that's when you have what we call a cusp. So your graph have a really sharp corner, okay, where at this particular point there's no derivative because it's increasing followed by a sharp decreasing. It's not like a nice curve, okay. So we have no slope here because slope changes dramatically from positive to negative. that at that point could be both. So therefore, if you look, okay, we have no derivative there, okay. So that's when we have what we call a cusp. Okay, and then when you try the second derivative too, you also don't see anything here, right? Because there's no concavity. There's no concave down or up in this particular graph. Okay, then the last graph is where you're going to, this is algebra review a little bit from pre-algebra days, or I mean pre-calculus days, where you do have x, y intercept. Okay, same thing. We said now our function is y equal to 3x over x plus 2. So if you set it equal to 0, okay, you do have your x and y intercept, but this time you have a vertical asymptote because you have a domain. Domain cannot equal to negative 2. So at negative 2, you can expect we don't see anything. We have no solution there. We have no function exists over there. So this is a discontinuous function. So that's the only thing difference. Now, if you look, okay, if you try to find a derivative as well, you're going to find out there's no solution, okay? Because if you look at this, okay, there's no where you're going to have a maximum or minimum point. Okay, but once again, the most important thing to consider for this section, though, okay, it's not really curve sketching. It's more this right here. Here's a conclusion. If you find the first derivative is set equal to 0, you will have a possible maximum minimum point. You can use a second derivative to test those points to find out if you have a concave up or concave down at that point. If you concave up, then you have a minimum point. If concave down, you have a maximum point. Another way you can test for maximum minimum point will be whatever the point that you find to the just find a number to the left or to the right to it and test it out with the first derivative. If the whatever number you plug in the first derivative is greater than 0, then you know that your function is increasing. If it's less than 0, it's decreasing. If you have an increasing followed by a decreasing, then you have a maximum. If you follow by a decreasing and an increasing, in other words, a concave up, then you have a minimum.